Hey everyone, Miss B here, and in this video we're looking at the Unit 2 Lesson 15 practice problems for Illustrative Math Algebra 1. So this is more practice with solving by elimination, but it involves some other concepts related to elimination. So we're gonna talk about those. So this is a system of linear equations for number 1, and we want to solve it without graphing. And we must show our work. So I'm going to highlight this. You must show your work in order to get full credit, especially on these questions. So please show all of your work. I'm going to show all of mine. Now here, I do actually have something that is already set up and ready to eliminate because I notice I have positive 4 and negative 4 as my coefficients on y. And if I have opposite coefficients, same number, but opposite in terms of like one's positive, one's negative, then I can just add both of these equations together. So 5x plus 10x, that would give us 15x. These two would create 0y, and then this would be equal to 46 plus 8, I believe, is going to be 54. Yeah, 54. Now, we're going to take that 54 and divide it by 15. We're not going to get a great answer from this. It's going to be a fraction, but it's not a repeating one, and that part is at least nice. So you can still feel free to use the decimal here. This is going to be 3.6. So from there, we can use any equation. I like the smaller numbers of the top equation better, so I'm going to plug in to that one. And I'm going to show 5 times 3.6, because that's my value for x, plus 4y should be equal to 8. So let's do this 5 times 3.6. I get that that is 18 plus 4y equals 8. So if we subtract 18 from both sides, we'll have 4y equals negative 10. Divide both sides by 4. And you'll get that y is negative 10/4 is negative 2.5. I'm going to stick with decimals since that's what I was using in the one above. So x value of 3.6, y value of negative 2.5. That is the solution to this system. They don't always come out to be whole numbers, but that's okay. For question 2, this one now just wants us to select all of the equations that share a solution. Now the nice thing is, in order to do that, I don't necessarily have to solve. I'm just selecting all of them that I know are equivalent equations. One of the ways we can make equivalent equations is by adding them together. We can also find equivalent equations by subtracting things. So let's try both of those methods. If I add 5 and 2 together, we'll get 7. So for the first one, I know I should have 7x. And then if I add negative 7 and positive 4 together, that's going to give me negative 3y. And then 24 and 26 makes 50. So it looks like by adding them together, I'll actually get b. So this is adding. And I'm going to call this equation 1 and equation 2, or like number 1 and number 2, just so that I have a specific order. 5x plus 4y is equal to 2x minus 7y. That is not going to be true for part C, because that would only be possible if they were equal to the same number over here, and they're not. So I can't set them equal to each other. But let's subtract. So let's actually do 5 minus 2. That's going to give me 3. And 4 minus negative 7 is like 4 plus 7, which is going to be positive 11, and then negative 2. So subtracting, so equation number 1 minus equation number 2 is going to give me E. So this is number 1 minus number 2. And the really nice thing about subtracting is that if you do the subtraction in one direction, you can do the subtraction in the other direction just by changing the sign of every single answer. So I don't actually have it subtracted in a different order here, because if I did, I would need to have like negative 3x minus 11y equals a positive 2, and I don't have that. But yeah, so it's just going to be these two, and that is going to be by adding, and then E is by subtracting. That's going to bring us down to question 3. Students performed in a play on a Friday and a Saturday. For both performances, adult tickets cost $8, not 8, $8, and students' tickets cost $S each. On Friday, they sold 125 adult tickets, and 65 students collected $1,200. And on Saturday, they sold 140 adult tickets and 50 student tickets and collected $1,230. This situation is represented by this system of equations. So they're giving us some context for a system of equations that they're providing to us. They want to know for part A, what could 265A plus 115S equals 2,430 mean in this situation? That is going to come from adding the two equations together. And so let's actually look at that first, and I'll show you what I mean. If we added everything here together, you would get an eraser. This would be 265A plus 115, yep, 115S, and then it's going to be equal to 2,430. So that's where we get it. It's from adding them together. So this looks like the totals from both nights of the theater production. So the play was a Friday and a Saturday. So this is going to be total tickets sold and money earned from Friday and Saturday night. Because we're just adding it together. And so the prices don't change or anything like that. Part B here says the solution to the original problem. So let me actually change my scroll direction here. Solution to the original system is the pair A equals 7 and S equals 5. So we want to explain why it makes sense that this pair is also a solution to this new equation. So we can say the solution represents the ticket prices. Because that is actually what they told us, that it was $A. So A represents dollars and S represents dollars. So those prices for admission are not going to change. So the solution represents the ticket prices. I'm even going to highlight my own answer here so you can see what I'm connecting it to, which are the same for both nights. So it should be the same for the total. I'll say the total as well. And there we go. That's why I think that it makes sense that it's also a solution to that equation, because that equation just represents the total of tickets they sold on Friday and Saturday, all put together. And those prices aren't going to change, so plugging in those prices should also make this equal. That's going to bring us then onto the next page. So, next page here says, which statement explains why 13x minus 13y equals negative 26 shares a solution with this system of equations? Well, I can see right away that this is not being added. If it was being added, we would have something different here. We would have 10, and then when we add a negative 3, that's just like saying 10 minus 3, which makes positive 7. These are actually being subtracted. So in order to get this here, this is a big subtraction problem. That's what creates the 13x minus 13y equal to negative 26. So let's read through our options here. First one says because it's the product of two equations in the system, so it has to share a solution. Product, this means that we are multiplying. It means it's the result of multiplication. And this is not the result of multiplication, so it is definitely not going to be this answer. B says that the three equations all have the same slope but different y-intercepts, and equations with the same slope but different y-intercepts always share a solution. I wouldn't say that necessarily. The slope on the last one is going to be basically 1 or negative 1, and that's not the same as the first two. So the slope is not the same for these at all. Okay, now C and D are a little more complicated, and these look like they might be similar. So they said, because 10x minus 3y is equal to 29, I can add 10x minus 3y to the left side and add 29 to the right side of the same equation. And adding equivalent expressions does not change the solution to the equation. Well, they're right that adding equivalent expressions does not change the solution to the equation, but we didn't have adding here. We actually found that this was through subtraction. So we're going to choose the same part, same explanation, but using subtraction, which is D. So this comes from subtracting equivalent expressions from each side does not change the solution. This key idea right here. That's why we would choose D. Now, 5 here asks us to select all equations that can result from adding these two equations or subtracting one from the other. So let's start by adding them up. If we added, we would get 4x minus 4y is equal to 16. And I see that here as choice C. And it does say select all, so I know this is not just my only answer. Let's actually subtract as well. Actually, I can leave that there. And we can say that this is add. Now, if I did x plus y equals 12, minus 3x minus 5y equals 4. X minus 3x is going to be negative 2x. Y minus negative 5 will be a positive 6y. And 12 minus 4 is going to be 8. So I want negative 2x plus 6y equals 8. I see that as choice B right here. And then if I reverse the order, and I did 3x minus 5y equals 4, and I instead subtracted the x plus y equals 12, you would see the same difference between these numbers, but instead they would just become opposite signs. So in this case, we would have, instead of negative 2, positive 2x. Negative 5y minus, minus that y would give negative 6y. And then 4 minus 12 would give negative 8. So that answer is going to be E. So our answers here are going to be B, C, and E. So like I said, you can kind of just swap these. So you might notice these two are very similar. They just have their signs swapped. And that is kind of a little shortcut you can use on that. So we're going to keep going. And then this is the last page here on the next one. It's 6 and 7. Now 6 I know it does have 2 parts, but they give us plenty of room for it. So I'm going to try to get this here off my screen. There we go. I know you guys can't see it, but it bothers me. So, all right, let's start with solving this system first. 7x minus 12y equals 180, and 7x equals 84. Now this one is set up so that substitution can be really easy. I am going to say here that I see 7x in both of these equations here. So I'm going to use this one that has 7x by itself and use 84 as the substitute for 7x. So we're going to take 84 and plug it in for the entire term here, since we're not just solving for x. I'm going to take 84 and plug it in that entire place. So I would have 84 minus 12y equals 180. We can subtract 84 from both sides, so negative 12y is going to be equal to 96. And then if we divide here by negative 12, we're going to get that y is equal to negative 8. You can bring that back. Actually, let me check that for myself, the 96 divided by 12, because I feel like that's a weird number. No, it's 8. Oh, that's why this one is weird. I was like, what am I doing? Um, I was looking here at 7x equals 84 for a spot to plug it in. But guess what? If I take it back to the 7x equals 84, there is no spot to plug it in. I can just divide both sides by 7. That's what it was. And get that x is equal to, in this case, 12. So here, my answer is 12 comma negative 8. I just did this problem earlier too, so I was like, wait, why is this not making sense? Because I did it a different way. Okay, we're going to use the same idea where we're going to plug in for an entire term and not just the variable on this next one. Because I noticed that for x, and 4x are both in these equations. So it looks to me like 4x is the teacher, and who is going to be the sub? Negative 16y is going to be the sub. So we're just going to pop that in place here of this 4x. So we'll have negative 16y, zoom out here a little, plus 27y is equal to 11. When you combine these two, you get 11y is equal to 11. That means you divide both sides and you'll get that y is equal to 1. We're going to go back and plug that into the original equation of negative 16y equals 4x. Negative 16 times 1 is equal to 4x. This is just negative 16 equals 4x. Divide both sides by 4 because the goal is to get the x on its own, and you'll get here negative 4. So our answer for this one is negative 4, comma 1. And that is this answer here. That's 6a and 6b. Now the last one here, the last question, does have two parts, but it's a big word problem, so let's break it down. Elena and Kieran are playing a board game. After one round, Elena says, "You earned so many more points than I did. If you earned 5 more points, your score would be twice mine." And then Kieran says, "Oh, I don't think I did that much better. I only scored 9 points higher than you did." So we want to write a system of equations to represent each student's comment and specify what our variables represent. So I'm going to define my variables above question A right here. I'm going to say that x is 1 and y is 1. And we'll say that x is Elena's score and y is going to be Kieran's score. So Elena says, if you earned 5 more points, your score would be twice mine. So that means plus 5, and it's going to be equal to, twice would be 2 times her score. So I would say Kieran's score plus 5 is equal to 2 times Elena's score. And then Kieran says, "I don't think I did that much better. I only scored 9 points higher than you did." So we're going to add those 9 points onto Elena in order to make her score even with Kieran's or equal to it. So this other one would be y is equal to x plus 9. Okay, those are my two equations. So if both students were correct, how many points did each student score? Well, the way I have this set up, I actually do have y solved for. Y equals x plus 9. So I can say that y is going to be substituted in for x plus 9. Or the other way around, x plus 9 will be substituted in and put in place of y in my other equation. So my other equation here was y plus 5 equals 2x. So instead of y, we're going to put x plus 9 plus 5 equals 2x. We don't need the parentheses because we don't have to multiply anything here. So this can just be x. And then 9 and 5 can become 14. That's equal to 2x. We actually subtract x from both sides, and we'll just get that 14 is equal to x. So that's going to be Elena's score. And then Kieran's, we take this 14 back up here, and we can say y is equal to 14 plus 9. So y is equal to 23. So how many points did each student score? So I'm going to say Elena scored 14 and Kieran scored 23 points. And that's going to be it. That is our entire assignment here. So hopefully my explanations helped it make sense. And if not, please make sure that you ask in person in class. And yeah, thanks for watching. This has been the Unit 2, Lesson 15 practice problems for Illustrative Math, Algebra 1.